one or two steps at the end. I'm going to use 18 because the smaller number is probably what I typically try to look for myself, but so 18 is going to be each of these denominators. So they're both going to be 18. Now again, if you use 54, 30, yes? Oh, you're going to keep, okay, just hang on a second. You can use 54, you might use 36, like there's kind of lots of numbers that 9 and 6 can both become. So yeah, go ahead.
The first one is 16 and the second is 13.
Yeah, so these become two new fractions, but they mean the same thing. This is just an equivalent fraction. So this one we had to multiply by 2. Hi, welcome back.
Thank you.
And then this one we had to multiply by 3. So whatever we do to the bottom, we have to do to the top. So if you're wondering where we got those numbers from. How are you? Happy birthday yesterday.
Thank you.
This is Miss Miller, if you guys don't know her. Probably a lot of the freshmen don't.
Probably not.
So Miss Miller is here as a support teacher, but she also, like, she's poor lady, is with me like all day, every day for like the last 3 years. She sits through like all of my classes. So know that she knows her stuff. So she basically takes this class like, I mean, how many times she's probably taken this class? Like 6 times. So she's like a superstar algebra student. So she'd be glad to help you. So like she, like during work time, she's willing to like pull some of you guys out if you want to work with her. And so just know that she is a great resource for you guys. So she had her birthday yesterday, and so got away a little bit. So so just know that like she's here for all of you guys. She's specifically here, maybe a little bit more for some students, but yeah, just know that she's a great resource for you guys. So and yeah, like it's like superstar algebra student. She's like super senior, like times a lot. All right, so we're gonna combine these two now. So we have a negative 16 and a negative 15. They're both negative, so you go more negative. So remember, you lost some more. We lost a total of 31, right? And then 31 happens to be a prime number. So nothing goes into 31 that I can think of, and other than 31 and 1. And so this is the simplified answer. Now, again, going back to Griffin's answer that he had used a 54, you just had a little bit of simplifying to do when you were done. Now, this is an improper fraction. Some of you guys, that's making you like a little twitchy, like you want to fix that. Leave it as an improper fraction, that's fine. If your calculator automatically switched it for you, like you used your calculator and it switched it, what does that end up being? Is it like a -1 and is that 13 18ths or something like that? That's okay. Like, I'm fine with that answer as well. This is probably, I'd just say leave it that way so for one, not to make another like mistake on it. All right, questions there? All right, number 2. What's our common denominator in this one? What did you guys get for your common denominator? What did you get for your common denominator? 40, yep. So this one, 40, sometimes like you're like, oh, there's got to be something smaller. This one, there's not. Just 40. 8 times 5 is 40. That's the smallest number they both can become. I always like finding the multiples of 5 because it's either a 5 or a 0 they end in. So the big numbers don't change unless you decided to change them to improper fractions. Now I have to decide. Now basically I'm just multiplying by the other one. So this one's times 8. And then this one's times 5. But we don't change those whole numbers. That doesn't change at all. And then we're ready to combine these. So 4 and 3 is 7. 15 and 8 is going to be 23. And then again, that's in simplest form right now, because 23 can't divide by anything. So like I said, if you guys struggle with adding and subtracting fractions, good news and bad news, we get to go away from adding and subtracting for a few days here. Today we're going to talk about multiplying and dividing, which is actually easier, which is kind of crazy because you learned multiplying and dividing after. And then tomorrow we'll go completely away from fractions for a few days. So just a heads up on kind of the plan for the rest of the week here. So we're going to talk about multiplying, dividing real numbers, positive positive negatives, but also fractions. It could be decimals. And so multiplying fractions is what we're going to talk about here. So when I'm multiplying fractions, we do not need a common denominator. Now you might say, I really want a common denominator. I'm going to tell you, it's just going to confuse you. So it's more work and it's confusing and you don't need it. So it's unneeded, so don't get common denominators. That's a waste of your time. And like I said, it ends up being confusing if you try to get common denominators for multiplying. So that's kind of good news, hopefully, for some of you. Because if you didn't like finding those common denominators, if that was a struggle, we don't have to worry about it here. So these two steps that we're going to do aren't really numbered as steps because the order you do them in doesn't matter. So you can do a couple of different things here, and it just depends on what order you want to do them in. Does anyone remember how to multiply something like example 1? You remember how to multiply fractions? Yeah, you can just multiply across the tops and across the bottoms. It's like, you're like, really, that's it? Now, I was waiting for someone to raise their hand and be like, cross multiply. We do not cross multiply here, and if you're thinking that, sorry. We don't get to, so this is not cross multiplying. Where cross multiplying shows up, just to kind of quickly, is when I have an equal sign between them. So if I have something like this, that's when you cross multiply. So we're not doing this. This is a no-no right now, so don't do that. Bad. Don't cross multiply. So like Kylie said, we're just going to multiply across the top and then multiply across the bottom. So I'm going to write that as a step, and then we'll actually do that. So multiply the tops, multiply the bottoms. That's straightforward. And 5 times 16 is that 80, I think. And so, yep, again, if you need a calculator, go ahead and grab one. I know not everyone's favorite thing is doing multiplication in their head. It's kind of my job, so I'm not so bad at it, so I don't mind it. But sometimes I'll ask for help. Now at this point, we do have to simplify. So we do have to simplify these because they're not simplified. So I'm going to write simplify, and then I'm going to add something else in. I'm going to write simplify / cross cancel, and we'll talk about that here in a second. So simplify or cross cancel. How can I simplify 30 and 80? Yeah. Divide both by 10. They both have that 0, so that's a really good clue that we can divide them both by 10. So this ends up being 3 over 8, which is our simplified fraction. So going back to my other little bullet point there, does anyone know what I was talking about when I said cross cancel? And so what I'm going to get at here is that these two things could be done in either order. So I could do one or the other first. So I'm going to show you guys an alternate way to what we just did, and some of you guys are like, why are we learning another way? Like that one worked for me. Is this might be a way you guys have seen before, and it might be easier if the numbers are bigger, and you don't want to have to multiply in your head, or you don't have a calculator handy. Does anyone know what we can do with this right now? Before we do any kind of multiplying. And it's called cross canceling, so I don't know if that seems, it jogs your memory at all. No? Anyone recall? So what cross canceling is basically simplifying before I multiply. Can I simplify any of those numbers? And the name cross maybe kind of helps that. It can be like diagonal or up and down. So if I look at 5 and 15, What can those both be divided by? By 5? Yeah, it ends up being 3, but we can divide them both by 5. So this would become a 1, this would become a 3. How about the 2 and 16? We can divide them by 2. That would be 8. So this is an alternate way. Now some of you guys are like, oh my gosh, what did she just do there? Why did she do that? And if you're okay with this first way, you can just ignore that I even spoke here. But at this point, we can do a little bit of simplifying. So I have 1 times 3 is 3. 1 times 8 is 8. So basically, we simplified before we even started. So that's also a possibility if you prefer. Now, if you're like, holy cow, it just blew my mind right there, I hated that, then ignore it. Like, so I don't often show multiple ways to do something because I kind of think sometimes they confuse you. But I think that's one that you may have learned before. And if you don't like it, ignore it. If you like this way or if you remember this, I'll bring it up from time to time. But either way, we got the same answer. So we're in a good spot. How about example 2? What's different about this? What do we need to remember with this one? Or what do we need to know? Does anyone know how to, because one of those isn't even a fraction. Anyone know what to do with that? Yeah.
I was told just put 100 on a 6.
Yeah, because we can make 6 into a fraction, even though we don't really like fractions. If we're working with fractions, we kind of want everything to be the same. So what Tucker said was we can make 6 into a fraction by just putting like a 1 underneath. Because I can divide any number by 1 and it doesn't change the answer. So we make this a new fraction now where we multiply. And now we can just, like we said, multiply across the top, multiply across the bottom, and simplify. If you're kind of into that cross-canceling thing, you can. I didn't see any like really excited faces over that. So I'm going to probably just multiply across the top. So 4 times 6 is 24. 5 times 1 is, or sorry, 15 times 1 is 15. And then can I simplify those two? Divide them by, yep.
Divide them
By 3, yep. So this ends up being 8 and then also 5. So we get an 8 over 5. All right. So before we get into dividing, because I want to make sure you really have multiplying down, and some of you guys are like, this is super easy and I like this, or whatever, or I'm still kind of lost. We're going to do whiteboards for a little bit. So what we're going to do, the point of the whiteboards before you guys get up, is that way all of you guys get a chance to like show what you know, and I'm not like just calling on the people who are outgoing or know the answer. And that way Miss Miller and I can come around and help you if you're struggling, and it kind of gets us all in the same spot. And the whiteboards are just sometimes more fun than just doing things on your note paper. So I'm going to say these 2 first rows. If you guys want to go grab a board, marker, and then usually the Kleenex works well as an eraser. Otherwise you can use the cloths, but there are only so many of those. And then you can take a few minutes to make sure your marker's working and draw like a picture or something, write a note to a friend. You'll notice my back of my boards have been very graffitied, so there's probably some comical things written on the back. Like, I don't know how that has happened over the years, but it has. So don't call the phone numbers on there. Next 2 rows, go back. It's just like bizarre things. Like some of them are like cries for help, and so. Yeah, there's a dino chicken on these over here too. So someone that's their like cat, like their tag.
Hi, Mom.
Somebody is like actually asking for like help, and so I'm a little worried about them that I never found out who that was. So. What's the one? Right. Guys, last 2 rows, don't grab markers. Now, if your marker's not working, feel free to throw it out and grab a new one. I know.
Chicken nuggets.
We're gonna be best buds and we're gonna be best buds. We're gonna be the three,
I don't even. What is that? I'm very confused.
okay, you can be that, I'm not.
Plus a nice soft portrait.
Yeah, mine was going to see my budget doesn't really eat.
That's paper.
Do you remember, have you guys, I know you saw the commercials with the cheetahs, the Chester cheetah.
I don't know.
I don't know, the Cheetos guy, they used to have like a character that was a cheetah that was cartoon.
Without a character.
And my high school physics teacher used to call me Chester Cheetah because I was always smiling. So like, Chester, you never know I'm smiling.
I still have it, man, so.
I know. I know, but my smile like gets totally, I try to smile with my eyes, so. Trying. Like I'm a super smiley person and I'm like, I feel like this like makes me just look angry all the time. All right.
This one says to the